An entire district in China stays cold without a single air conditioner. Thousands of offices, hotels, shopping malls, glass towers stretching into the sky. Yet look outside, there are no compressor units, no metal boxes hanging beneath windows, no rows of humming machines on the rooftops, nothing. And yet, step inside any building and the temperature instantly drops. So where is all that cold air coming from? The answer isn't inside those buildings. It isn't on the roof. It isn't even above ground. It's hidden beneath the streets, inside a machine powerful enough to cool an entire business district. But that underground machine is only the final piece of a much bigger plan. Because China didn't solve extreme heat by building a better air conditioner. It started redesigning the entire city. From creating rain to reviving thousand-year-old architecture to roads that stay cooler under the summer sun. By the end of this video, you'll understand how China is trying to cool an entire city without traditional air conditioners. This story didn't begin with a new invention. It began with a crisis. In the summer of 2022, China experienced the longest and most intense heat wave in its recorded history. For more than 2 months, temperatures pushed past 40 degrees Celsius across large parts of the country. Rivers shrank, reservoirs dried up, even the mighty Yanks fell to unusually low levels. But the biggest problem wasn't the heat itself. It was electricity. As millions of air conditioners switched on at once, power demand exploded. Hydroelectric dams, already weakened by low water levels, couldn't keep up. Factories were ordered to shut down. Some cities even rationed electricity just to keep homes cool. It exposed a dangerous weakness. The hotter the weather became, the harder air conditioners worked, and the harder they worked, the closer the power grid moved toward failure. Simply installing more air conditioners would only make the problem worse. So Chinese engineers asked a completely different question. Instead of cooling every building separately, what if you could cool the entire city itself? That single idea changed everything. But before they redesigned buildings or buried giant cooling plants beneath the streets, they tried something even more unbelievable. They tried to cool the sky itself. If this video helped you see the world a little differently, that's exactly why we make these. Hit subscribe button and turn on notifications so you don't miss the next one. Drop a like, it takes 2 seconds. Now, let's keep going. The first solution didn't start underground. It started thousands of meters above it. During the 2022 heat wave, China activated the world's largest cloud seeding program. The goal wasn't to create rain from a clear blue sky that's impossible. Instead, scientists looked for clouds already carrying moisture, then encouraged them to release it sooner. Aircraft, rockets, and drones released tiny particles of silver iodide into the atmosphere. Those particles acted like microscopic ice crystals. Water vapor gathered around them, forming larger droplets until gravity finally pulled them to the ground. Within hours, rain began falling across parts of the drought-stricken region, cooling the air, refilling reservoirs, and helping dams generate power again. It wasn't a permanent fix. Cloud seeding only works when suitable clouds already exist. You can't make rain out of an empty sky. But the operation revealed something important. China wasn't fighting heat with one invention. It was building layers of protection. If one method wasn't enough, another would take over. And surprisingly, the next idea wasn't new technology at all. It was more than 1,000 years old. Long before electricity, people in southern China had already found a way to survive brutal summers. At the center of traditional homes, they built a narrow opening called a skywell. As hot air naturally rose, it escaped through the opening above, continuously pulling cooler air through the rooms below. No fans, no motors, just physics. Modern architects realized the same principle could work inside skyscrapers. Today's high-rises use vertical ventilation shafts inspired by those ancient designs, moving heat upward naturally and reducing how much mechanical cooling each building needs. A 1,000-year-old idea was quietly helping cool 21st-century cities. But even that couldn't solve one problem. The streets themselves were turning into giant heat batteries. The next problem wasn't the buildings. It was everything around them. Walk across a city on a hot afternoon and you'll feel it immediately. The roads, the sidewalks, the rooftops don't just absorb heat, they store it, then keep releasing it back into the air long after the sun goes down. That's why cities often stay several degrees hotter than the countryside nearby. Engineers call it the urban heat island effect. China decided to attack the problem at street level. Instead of covering roads with traditional black asphalt, some cities began testing reflective pavements, special coatings that bounce sunlight back into the sky instead of trapping it in the road. Other surfaces were made porous, letting rainwater seep in and slowly evaporate. That evaporation quietly carried heat away, cooling the streets without using any electricity. Tests showed some of these roads staying 7 to 14 degrees Celsius cooler than ordinary asphalt under the same sun. That may not sound dramatic, but across an entire city, it changes the temperature of everything above it: the air, the buildings, even the people walking outside. Then engineers asked an even stranger question. What if a building could cool itself without using any power at all? The answer came from a coating that looks almost like ordinary white paint, but behaves very differently. Instead of absorbing sunlight, it reflects almost all of it while releasing heat as infrared radiation through a part of the atmosphere where that energy can escape directly into space. No electricity, no moving parts, just a surface quietly sending heat away, 24 hours a day. Some test buildings treated with these coatings recorded indoor temperatures several degrees lower, while cutting cooling energy by as much as 40%. One layer cools the sky, another cools the buildings, another cools the streets. But China still faced one final challenge. How do you cool an entire district with a single machine? That machine is hidden beneath the streets of Shenzhen. Above ground, everything looks completely ordinary, just another block of glass and concrete. But several floors below, an industrial cooling plant works around the clock. Instead of every building running hundreds of its own air conditioners, one central facility produces massive amounts of chilled water. That water flows through a network of insulated underground pipes, connecting building after building, just like a city water system. Inside each tower, the cold water absorbs heat from the air, then returns underground, where the plant cools it again and sends it back out. The cycle never stops. One machine serving an entire district. The result is simple. Buildings no longer need thousands of separate outdoor compressors. The constant noise disappears. Maintenance gets easier. And because one large system is far more efficient than thousands of small ones, electricity consumption drops dramatically. According to local reports, Shenzhen's district cooling system saves around 130 million kilowatt-hours of electricity every year, enough to power tens of thousands of homes, while preventing roughly 130,000 tons of carbon dioxide emissions annually. It's one of the largest district cooling projects ever built. And once you know it's there, those spotless skyscrapers suddenly make sense. The cold air was never coming from the buildings. It was coming from beneath your feet. But even a hidden cooling plant has one limitation. It can cool buildings. It can't cool the person walking outside in the summer heat. So engineers asked one final question. Instead of cooling the city, what if you could cool the person directly? Even the world's most advanced cooling plant can't protect someone standing in the middle of the street. So China began solving the problem at the smallest possible scale: the person. Across many cities, solar-powered cooling stations have appeared at bus stops, public squares, and subway entrances. During the hottest hours of the day, the same sunlight creating the heat helps power cool air for the people waiting below. Then came wearable cooling devices, neck coolers, portable misting fans, lightweight cooling vests. Some use a tiny solid-state cooling chip pressed against the back of the neck, where blood vessels run close to the skin. As heat leaves the body, core temperature begins to fall. Instead of cooling an entire room, the device cools the person wearing it. A simple idea, but during extreme heat, it can be the difference between discomfort and heat stroke. And that's what makes China's approach different. It isn't one invention. It's an entire system. Rain from the sky, ancient building designs, cooler roads, heat-reflecting roofs, underground district cooling, and wearable technology all working together. Each layer removes a little more heat. Each layer reduces the pressure on the next. By themselves, none of these technologies would transform a city. Together, they just might. But perhaps the biggest lesson has nothing to do with air conditioning at all. For decades, the world treated extreme heat the same way. build more air conditioners, use more electricity, hope the grid can keep up. China chose a different path, reducing heat before it could become a problem, instead of fighting it inside every building. Will every one of these ideas become the global standard? Probably not. Some are expensive. Some only work in certain climates. Others are still being tested. But one thing is already clear. As heat waves become longer, hotter, and more frequent, cities can no longer rely on air conditioners alone. The future of cooling may not be a better machine hanging outside your window. It may be an entire city, engineered to stay cool from the ground up. And if that future arrives, people may remember the traditional air conditioner the same way we remember the coal furnace, not as the final solution, but as the first step. Subscribe for more engineering stories that are reshaping the future.